Imagine you're an astronaut, floating in the vast emptiness of space. What's the one thing you can't live without? Oxygen. Oxygen is the lifeline of space exploration. It's not only the precious gas that keeps astronauts alive, allowing them to breathe in an otherwise inhospitable environment, but it's also a crucial component of rocket fuel, powering spacecrafts through the cosmos. Back here on Earth, we take oxygen for granted. It's constantly being produced by our leafy companions, the plants, through a process known as photosynthesis. Sunlight, water, and carbon dioxide are all it takes for plants to churn out the oxygen we need. But once we leave the confines of our planet, we're left without this natural oxygen factory. So the question arises, how do we ensure a consistent supply of oxygen when we are millions of miles away from our green friends? Creating oxygen in space is not as simple as it sounds. It's a challenge that has puzzled scientists for decades. Imagine being millions of miles from Earth, surrounded by the vast emptiness of space. There are no plants to produce the oxygen we so desperately need to survive. Now, couple that with the limited resources available on a spacecraft, and you've got a real space oxygen dilemma. The need for self-sufficiency becomes vital. You can't just open a window and let in a fresh breeze. And let's not forget the potential dangers of running out of oxygen in space. Without oxygen, life as we know it ceases to exist. Astronauts could be facing anything from impaired judgment due to hypoxia to the worst-case scenario, suffocation. As you can see, the stakes are high, but as they say, necessity is the mother of invention. Over the years, scientists have developed several methods to produce oxygen in space. Each of these methods brings its own set of advantages and limitations, but they all strive towards the same goal: to create a sustainable life support system for astronauts venturing beyond the confines of our home planet. Let's start with electrolysis of water. This is a process where an electric current is passed through water to break it down into its basic components: oxygen and hydrogen. The oxygen can be used for breathing, while the hydrogen can be used as a source of energy. This method is efficient and has been used successfully on the International Space Station for years. However, it requires a substantial amount of water, a resource that is not readily available in space. Now let's talk about chemical reactions involving lunar and Martian soil, also known as regolith. You see, regolith contains about 45% oxygen by weight, locked inside mineral and rock formations. Scientists have been experimenting with various techniques to extract this oxygen. One such method involves heating the regolith to extreme temperatures, which causes the oxygen to separate from the other elements. Another technique uses chemical reactions to liberate the oxygen. These methods have the advantage of using resources readily available on the Moon or Mars, reducing the need to transport materials from Earth. However, they also present challenges, such as the need for high-energy inputs and the handling of potentially hazardous byproducts. There's also the method of photosynthesis. Yes, the same process that plants use here on Earth to convert sunlight, water, and carbon dioxide into oxygen and glucose. Scientists are exploring the possibility of using algae or other photosynthetic organisms in space to generate oxygen. This method is potentially sustainable and renewable, but it also poses significant challenges in terms of the long-term survival and maintenance of these organisms in the harsh conditions of space. But among all these methods, one stands out for its efficiency and sustainability. The method that has caught everyone's attention involves a little-known technology: solid oxide electrolysis. It's a process that uses heat and electricity to convert carbon dioxide into oxygen. Here's the fun part. Mars, our next big destination, has an atmosphere that's primarily carbon dioxide. Can you see where this is going? Solid oxide electrolysis could potentially turn Mars into our own cosmic gas station, providing the much-needed oxygen for future missions. But it's not just about filling up the tank, it's about life support too. Imagine astronauts being able to breathe Martian air thanks to this process. This technology doesn't just hold promise for Mars, it could be a game-changer for long-term space missions, even those beyond our solar system. It's about self-sufficiency, about not being tethered to Earth for supplies. With this technology, the dream of self-sustaining space missions is closer than ever. So there you have it, the ultimate guide to space oxygen production. From the indispensable role of oxygen in space exploration to the complexities of producing it in an environment with limited resources, we've covered it all. We've also delved into the various ingenious methods like electrolysis and chemical reactions that are making the dream of self-sufficiency in space a reality. Remember, every breath an astronaut takes in space is a testament to human ingenuity and the relentless pursuit of knowledge. If you're as fascinated by space exploration as we are, make sure to share this video. Oxygen production in space is a complex but vital part of our journey to the stars. If you've enjoyed learning about it, hit the like button and consider subscribing for more deep dives into space science. And don't be a stranger, drop a comment below with your thoughts on space oxygen production. Until next time, keep looking up. The cosmos has a lot more secrets to reveal.